This video covers this week's math homework for Cheyney from August 28th until September 1st. Remember that at any point you can pause this video or rewind this video to hear me explain the concept again or to work on whatever question you're listening to before you hear the next one. We'll start with Monday. Monday's homework focuses on basic ratio writing. Question 1 says, in a fruit basket, there are 9 bananas, 4 apples, and 3 plums. Notice that I circled all the math information and I also circled the label. The ratio of bananas to apples is 9:4 because in every fruit basket, there are 9 bananas for every 4 apples. Questions B and C are very similar to question A. You're simply determining for every blank, there are blank. In question D, we have to think a little bit deeper because question D says, for every 3 bananas, there is 1 blank. But when we look at the list, we can see that 3 bananas isn't an option. Let's draw out what a fruit basket looks like. In a fruit basket, there are 9 bananas, there are 4 apples, and we know that there are 3 plums. Let's zoom in. If I split my bananas into groups of 3, because again, there are 3 bananas, I'm essentially dividing my fruit basket into 3 equal groups. The tricky part is, if I tried to split my apples into 3 equal groups, I would end up with an apple left over that I had to split into thirds. So I know that for every 3 bananas, there isn't 1 apple. There's 1 apple and a third of an apple. However, if I split my plums into 3 equal groups, for every 1 plum, there are 3 bananas, or for every 3 bananas, there is 1 plum, which is exactly what question D says. This is a good time to pause the video and finish answering question 1. I didn't do B and C, so you'll have to do that on your own. I'm going to give a hint on question 3 before I move on to Tuesday. In question 3, you're writing a real-world situation to represent a ratio. They've given you the numbers to use when you write the real-world situation. In A, your ratio should start with for every 5, and it'll be for every 5 something. We don't know what. There is 1 something. And your job is to come up with a real-world scenario that makes sense. That's exactly what you're doing in B and C. And in question D, you're choosing the numbers on your own. I'm about to move on to Tuesday night's homework, so if you're coming back tomorrow, you can X out. If you're doing both tonight, press pause, finish question 3, then come back for Tuesday. On Tuesday night's homework, we have some review questions that test our multiplicative reasoning skills. This video will use question 1 as the model. Question 1. The Turner family uses 548 liters of water per day. The Hill family uses 3 times as much water per day. How much water does the Hill family use per week? Notice how I circled the key numbers with labels, and then I also boxed the other important vocabulary. Per day is important because it tells us when they're using that amount of water. I can write a T for Turner, and I'm going to write T per day. I know that the Turner family is using 548 liters of water per day. Now let's think about the Hill family. I know that the Hill family is using 3 times as much as the Turner family. And so I need to multiply that 548 times 3. Now, 548 times 3 gives me the amount of water that the Hill family is using per day. And a common mistake is to stop there. But the question asks us, how much water does the Hill family use per week? Which means we have one more step. We need to take the amount of water that the Hill family uses per day and we need to multiply it by 7 for 7 days of the week. That tells us that the Hill family uses 11,508 liters of water per week. And while I didn't ask you to write a full sentence here, you should have a labeled and circled final answer so that I know where to look. Notice how when I did question 1, I broke down the question with annotations. Then I went step by step to solve. Be sure that you are using this caution as you move through questions 2 and 3 on Tuesday night's homework. This is a good time to pause the video because I'm about to move on to Wednesday. On Wednesday night's homework, you're going to be practicing with equivalent ratios, and we'll use question 1 as our example. Question 1 asks, are the ratios 2 to 3 and 4 to 6 equivalent? We can stack them on top of each other to start thinking about it. I know that 2 times 2 is equal to 4, and I know that 3 times 2 is equal to 6, which means, yes, they are equivalent. And the reason why they are equivalent is because I can multiply 2 by 2 and 3 by 2 to produce the new ratio. So I'm simply going to write they're equivalent because I can multiply 2 and 3 by 2, that's my factor, to produce the new ratio, which is 4 and 6. This is always how we set up equivalent ratios. We're multiplying both sides of the ratio times the same thing. You'll want to keep that definition in mind when you work on Wednesday night's homework. There's also a reminder on the last page of this homework packet. Finally, we're at Thursday, and on Thursday's homework, we're focused on a foundational skill, area in perimeter. We'll use question 1 as our example. Question 1 says, a poster is 3 inches long. It is 4 times as wide as it is long. A wants us to draw a diagram of the poster and label its dimensions. I'm going to assume that the poster is a rectangle with a length of 3 inches. Now, we have to be careful. The width is not 4. The width is 4 times as long as 4 times as wide, rather, as the length, which means the width is 3 times 4, which is 12 inches. So we drew our diagram and we labeled our dimensions. Remember that if one side of a rectangle, like this side here, is 3 inches, we can assume that the opposite side is also 3 inches. And same with the width. If we're at 12 inches, we can assume that the width of the opposite side is also 12 inches. And to find the perimeter, we simply need to add up all the lengths, because the perimeter, remember, is the distance around the shape, which is 30 inches. And that's inches, just plain old inches, because we're measuring length. Whereas the area is the length times the width, or 36 inches, and I'll write the squared before, 36 square inches. You might be thinking, well, why did it change? Well, area doesn't measure length, length being how long around the shape. Area measures how much space does the shape cover or fill, and so our units are square inches. And this is also all on the homework helper page, which is on the final page of your homework packet. That's the end of this week's help video. If you need additional support, please make sure that you're checking in with Ms. Kinez before the end of the week.